So the next thing I want to prove to you guys is I want to prove that let's see, that the derivative of f inverse is 1 over f prime of f inverse. Okay, so that's a really funky formula, but honestly I have trouble remembering this formula, and the way that I remember it is I just kind of like derive the formula every time. In other words, I figure out what the formula is doing this little proof I'm going to show you. It's pretty quick, pretty easy, but you do have to start with the very first step. It has to stick in your mind fairly well. Here's the first step. The first step is to know this fact. Something that we should have learned or whatnot in our pre-calculus or algebra 2 classes, that if you plug an inverse function into itself, if you plug the inverse of a function into the function itself, basically, like, you can think of it like the f and the f inverse cancel each other out and they just leave x. So this is your starting point, okay? Now what we're going to do is we're going to take the derivative on both sides. So I'm going to do the derivative with respect to x of this composite function, which means I'm going to have to use chain rule, right? Now over here, the derivative of x with respect to x is going to be 1, right? Over here, we've got to do our chain rule. We're going to have the derivative of the outside function, so it's going to be f prime, and we won't be changing the inside for that. And it gets multiplied by the derivative of the inside. Which is what I'm trying to find. I want to know, what is this equal? Well, all I have to do is divide both sides by this portion that it's multiplied with, and we end up with our final answer. So the derivative with respect to x of f inverse of x is 1 over f prime of f inverse of x. So it's really intuitive and straightforward. You just need to remember that in the beginning, and you can kind of work your way to what the derivative of f inverse is. Now we're going to use this sort of mentality here, this sort of thinking, to do our final proofs that I'm going to be sharing with you guys, which is the derivatives of the arc functions. The arc functions are the inverses of the trig functions. And so I'm going to use this type of thinking to do those. In other words, we're not going to be using the limit definition of a derivative to find or prove these derivatives. We're going to be using this concept of the derivative of an inverse to do it. So, see you on the next video.